Imagine Earth millions of years ago, a time when the planet was vastly different from what we know today. The planet was dominated by oceans, teeming with life of all shapes and sizes, from the tiniest plankton to the largest sea creatures. Among these myriad forms of life were fish, creatures perfectly adapted to their watery world, navigating the currents with ease and grace. But the environment was not static. Over millions of years, seas rose and fell, and climates shifted dramatically, altering the landscape in profound ways. Some freshwater pools began to dry up, becoming treacherous and inhospitable places for the fish that once thrived there. This presented a dire challenge for these aquatic creatures: adapt to the changing conditions or face extinction. In response to these harsh conditions, some fish began to develop remarkable traits that allowed them to survive in these shrinking puddles. They started to evolve primitive limbs, enabling them to navigate the shallow waters more effectively. This adaptation would eventually lead them down an extraordinary path to a new world: the land. These early fish were taking the first steps, quite literally, towards a monumental shift in the history of life on Earth. These early pioneers were not seeking a terrestrial life. They were simply trying to survive in an increasingly challenging environment. The struggle was immense, and the effort required to move across the muddy terrain was visible in every wriggle and gasp for air. The ability to gulp air in oxygen-deprived water or wriggle across land to a nearby pond offered a crucial survival advantage. These adaptations were not just about moving, they were about finding new ways to breathe and live. Little did these pioneering fish know, they were setting the stage for one of the most significant events in the history of life on Earth: the transition from water to land. This monumental shift would pave the way for the evolution of countless terrestrial species, including our own distant ancestors. The journey from fin to limb is a story told through fossils, a narrative etched in stone over hundreds of millions of years. These ancient relics provide a window into the past, revealing the incredible transformations that life on Earth has undergone. Fossils reveal a fascinating transition, a record of ancient life preserved in stone. They tell us about the gradual shift from aquatic to terrestrial life, a monumental change that paved the way for the diversity of land animals we see today. This transition was not a single event, but a series of small, incremental changes. It began with fish that had fins, which over time evolved into limbs capable of supporting their weight on land. One of the key players in this evolutionary drama were the lobe-finned fishes. Unlike ray-finned fish, which have delicate fan-like fins supported by bony rays, lobe-finned fish possessed fleshy, muscular fins with a sturdy skeletal structure. This unique fin structure, so different from the fins of most fish today, provided the framework for the evolution of limbs. These fins were not just for swimming, they were robust and versatile, capable of bearing weight and allowing movement in shallow waters and muddy environments. Over millions of years, bones within these fins gradually changed shape and size. What were once fins used for swimming slowly transformed into stronger, more robust appendages, capable of propelling these creatures across land. This transformation involved the elongation of certain bones and the development of joints, which allowed for greater flexibility and movement. This was not a sudden leap, but a gradual process, with each small change offering a slight advantage in navigating the challenging environments these fish were encountering. As these early pioneers ventured onto land, they faced new challenges and opportunities, from finding food to avoiding predators. The fossilized footprints of these early land animals provide further evidence of this remarkable journey. Each step they took marked a significant milestone in the evolution of life on Earth. These ancient fish, through countless generations, adapted to their changing world, slowly but surely transforming fins into limbs and water dwellers into land pioneers. Their story is a testament to the power of evolution and the incredible adaptability of life. One of the most compelling pieces of evidence for this fin-to-limb transition lies in the bones themselves. When we compare the fin bones of a lobe-finned fish to the limb bones of a land vertebrate, the resemblance is striking. The same basic bones are present, arranged in a similar pattern, though with modifications. This shared skeletal structure is a powerful testament to their shared ancestry, whispering tales of a time when fins first dared to become limbs. Imagine a fish fin, gradually becoming stronger, the bones within it thickening and rearranging. Over generations, these changes allowed these creatures to push themselves through shallow water to support their weight on muddy bottoms. These adaptations, driven by natural selection, were the stepping stones to a terrestrial life. In the Arctic reaches of Canada, a remarkable fossil was unearthed, Tiktaalik. This 375-million-year-old creature is a true icon of evolution, a missing link between fish and land-dwelling vertebrates. Tiktaalik possessed fish-like features such as scales and fins, but it also had a flat head with eyes on top, a neck, and sturdy limb-like fins that could support its weight. Tiktaalik's fins were neither fins nor feet, but something in between. They had the beginnings of wrist bones, allowing for a range of movement not seen in earlier fish. This fishapod, as it is sometimes called, provides a breathtaking glimpse into the evolutionary transition from water to land, capturing a pivotal moment in the history of life. Section 5. Breathing on land, a breath of fresh air. The transition to land wasn't just about evolving limbs, it also required a new way to breathe. This monumental shift in habitat necessitated a complete overhaul of the respiratory system. Fish use gills to extract oxygen from water, but on land, this system doesn't work. Gills are designed to function in an aquatic environment, where water flows over them, allowing for the exchange of gases. Early land vertebrates had to evolve a way to breathe air. This was a significant evolutionary hurdle, as the air is much less dense than water and contains different concentrations of gases. Some fish, like lungfish, already had primitive lungs, likely an adaptation for surviving in oxygen-poor water. These lungs were rudimentary but provided a crucial advantage in environments where oxygen levels in the water were low. These lungs, simple sacs connected to the digestive system, allowed them to gulp air from the surface, providing a vital lifeline in stagnant water. This ability to breathe air gave them a survival edge in challenging conditions. As these fish ventured further onto land, the ability to breathe air became increasingly important. The transition from water to land was gradual, with these pioneering fish spending more time in shallow waters and on muddy shores. Over time, their lungs became more complex, able to extract oxygen from the air more efficiently. This gradual evolution of the respiratory system was crucial for their survival and adaptation to terrestrial life. This adaptation, coupled with the evolution of limbs, paved the way for a permanent move onto land. The development of lungs and limbs were interlinked, each supporting the other in the quest for a new life on solid ground. Section 6. From fins to feet, leaving footprints in time. Fossils of early tetrapods, the group that includes all land vertebrates, tell a remarkable story of adaptation. Footprints, fossilized in ancient mud, provide tangible evidence of these creatures walking on land. These prints, some of the earliest evidence of vertebrate life on land, mark a pivotal moment in evolutionary history. They tell of creatures leaving the water behind, venturing into a new and challenging world. The transition from fins to feet was a gradual process, with each step leaving its mark in the fossil record. Bones rearranged, digits emerged, and footprints grew clearer. These changes, driven by natural selection, allowed early tetrapods to explore and exploit a world previously inaccessible to vertebrates. Section 7. A world transformed, the rise of land vertebrates. The transition from water to land was a defining moment in the history of life. It opened up a vast new world for vertebrates to explore, leading to an explosion of diversity. From those humble beginnings, a staggering array of creatures evolved: amphibians, reptiles, birds, and mammals, all tracing their ancestry back to those intrepid fish that first ventured onto land. This evolutionary journey wasn't just about conquering land, it was about the transformation of the planet itself. Plants had already begun to colonize the land, creating new ecosystems. The arrival of vertebrates on land added another layer of complexity to these ecosystems, forever changing the face of the Earth. Section 8. Our inner fish. Unlocking the secrets of our past. The story of the transition from water to land is not just ancient history, it's a story that's still unfolding within our own bodies. Our limbs, our lungs, even our sense organs, all bear the hallmarks of our aquatic ancestry. By studying fossils like Tiktaalik and comparing our anatomy to that of fish, we can trace the evolutionary journey that led to our own existence. This journey reminds us that we are a part of nature, connected to all other life on Earth through a shared evolutionary history. Our bodies are living museums, carrying within them the legacy of our aquatic past, a past that continues to shape who we are today. Section 9. A legacy etched in bone. The story of how fish evolved to walk on land is more than just a fascinating tale of adaptation, it is a testament to the power of evolution. It reveals how life, faced with challenges, can find remarkable solutions leading to extraordinary transformations. The legacy of this transition is etched in our bones, in our DNA, and in the incredible diversity of life that surrounds us. It is a legacy that continues to inspire wonder and remind us of the interconnectedness of all living things.